Welcome to lesson 37. We're going to be graphing on a complex plane in this video. Let's go over to our notes. We have here multiplication. So there's going to be two things we're going to be doing. We're going to be doing operations with complex numbers, another example, and then we're going to graph. But if you're following along and you want to follow along with our vocabulary, we are going to be talking about complex numbers. We're going to be talking about operations. So adding, subtracting, multiplying, and dividing are all operations. We're going to be using box method to FOIL. We're going to combine like terms. So we have combined like terms here. We are going to be talking about a plane, a coordinate plane. In this case, it's going to be a real and imaginary plane where we are going to plot points on a complex plane, and I will add more on there as they come up. So first we are going to verify that -1 plus 2i and -1 minus 2i are solutions to this quadratic. Adding that onto my vocabulary list. Okay, so what that means is that we have to substitute in our values into our quadratic. Substitute to see if indeed the left-hand side is going to equal the right-hand side. So if I just gave you an example, x squared minus 5x plus 6 is equal to 0. This is just an example, and I said verify that 3x is equal to 3 is a solution. What that means is I'm going to substitute in my x is equal to 3 into my equation, minus 5x plus 6 equals 0. So instead of x, I'm going to put parentheses here. And what I'm going to do is I'm going to verify that x is equal to 3 is a solution. So I would plug in 3 here, plug in 3. Anywhere there's an x, I would plug in a 3 to verify that 9 minus 15 plus 6, is that equal to 0? This is me verifying. I'm trying to see my left hand and my right hand side of the equation is indeed true. So I get -6 plus 6 is equal to 0. 0 is equal to 0? Yes. So the fact that I proved the left hand side is equal to the right hand side means that I have verified that is indeed a solution. Okay, so this was just an example. I'm going to get rid of this, and we are going to verify that this complex number, these two complex numbers, are indeed solutions to our quadratic. So it means the same thing. I'm going to take my quadratic, and I am going to plug in and substitute in, as another way of saying it, my solutions to verify that they are indeed solutions. So -1 plus 2i, and then -1 plus 2i. Notice, I'm only doing one of these at a time. So I'm gonna get rid of this. I'm only gonna do one solution at a time. And in this case, I'm doing the first one. Using our order of operations, parentheses, exponents, multiplication, division, left to right, and adding and subtracting from left to right, I'm going to follow that in order to simplify this. I see that the parentheses are simplified all the way. They're complex numbers. And now I'm moving on to my exponents. So my exponents, I have this here. How am I going to simplify this? We are going to use our trusty box method, our very favorite box method, which means we're going to fill out the outsides, -1, 2i, and then -1 and 2i, and then we are going to complete this box method. So I'm going to zoom into this box method. You can probably beat me to it, but one of the great things about this is I get to show you how to multiply and verify this complex number, but we get to practice our operations with complex numbers. So we spent a whole video and a whole day on just being able to add, subtract, multiply, and divide with these imaginary numbers, and here we're going to practice it some more. So -1 times -1 is +1. 2i times -1 is -2i. 2i times -1 is -2i. 2i times 2i is 4i squared. Oh, this is special. 4i squared, that's going to be 4 times -1, because I squared is equal to -1. If you do not know this, if this confuses you in any way, please go back to a previous video. Otherwise, the rest of this video is not going to make sense. So this 4i is actually equal to -4. Okay, 4i squared is equal to negative 4. If you have questions on it, make sure you draw a caution sign and you ask questions tomorrow. Okay, I'm going to combine all the like terms inside of my box. What is this? Negative 4. So I get, oh goodness. 1 minus negative 4 is negative 3 minus 4i. Okay, so negative 3 minus 4i is actually what's going to go in to substitute this. Negative 3 minus 4i. So see my scratch work for details. Okay, from here, I'm going to distribute this. So I have negative 2 and then plus 4i plus 5. Is this equal to 0? Here's where I'm verifying. So I'm going to verify, and I have negative 3. I'm going to combine like terms from left to right. So negative 3 minus 2 is negative 5. And then I have negative 4 plus 4i. I'm just going to write that. I'm going to write that out. Negative 4i plus 4i plus 5 is equal to 0. Now, this 5 and this 5 will go to 0. This negative 4i and this positive 4i is going to go to 0. So 0 is equal to 0. And yes, I have verified it. For the sake of time in this video, what you are going to do is you are going to take negative I minus 2i, and you are going to verify that it is indeed a solution or not to this quadratic. So you need to fill this out. Negative 1 plus 2i, negative 1 minus 2i. Show your scratch work and verify that indeed the left-hand side of the equation is equal to the right-hand side of the equation. Okay, now we're going to move on to graphing it. But before you move on, if you need to summarize, pause, annotate, ask questions, there was a lot of steps going on here. So go through and annotate your steps, 1, 2, 3, 4, add in your big ideas and questions, and then meet me on the next page to fill out graphing. Okay, so graphing complex numbers is going to feel very familiar, but it may look a little different. We usually have, this is our y-axis and this is our x-axis. Now, for complex plane, you are going to actually not write x and y on your axes. You should take a second and just copy down this graph here because we are going to plot some points. Hopefully you've copied down the graph. This is going to be our real numbers, real. All these axes, the numbers on this axis, the negative ones and the positive ones are all going to be our real numbers, or our A value, A. The y-axis, what we traditionally call the y-axis, is now going to be our imaginary axis. And instead of just 5 and 4, it's going to be 5i, and it's going to be 4i. This is how our units are going to work. Imaginary units, 3i, 2i, 1i, 0i, negative 1i. So I'm going through down the y-axis and I'm just filling in I next to each of them because this is how we're going to use our complex plane. Complex plane. Okay, now I'm going to show you how fun it is to graph these. So I'm going to take this color, A, 5. So I'm going to go 5 along my real axes, and then I'm going to go positive 2 to positive 2i. Done. Okay. B, 3, negative 2i. So I'm going to go 3 along my positive or my real axes, and then negative 2i along my imaginary axes. And I'm just going to plot it. So let's do a different color. Negative 2, and then negative 4i. It's going to be down here. I'm sorry if you can't see this green color very well. How about just negative I? There's no real number part, so it would just be 0 minus I. So we would go to 0, and then we'd go to minus I. Okay. We have 1/2 and then positive I. So I'm going to go about 1/2 and then a positive I. And I'm just plotting points. Simple as that. The imaginary axis is on the y-axis, and the real, imaginary, or BI, is on the real numbers are on the x-axis, and the imaginary on the y-axis. Okay, let's finish graphing this. Root 2. Root 2 is about 1.4 minus 3i. So if you plug that into a calculator, you would have found that it was about 1.4. So 1.4 and then negative 3i. All right, negative 3/2, about negative 1.5. Negative 1.5. And then plus root 3 over 2 works out to be, I think, around 0.9i. You can plug that into a calculator and you can find that out. So I'm going to go negative 1.5 and then about 0.9i. And it's okay that we have decimals and fractions because it also works on this type of complex plane. So pat yourself on the back. We labeled each point. I guess we didn't label it by the letter, but you could go back and you could label everything, but we kind of color coordinated it. So for you, if you're not working with colors, just go ahead and fill in the letter that goes with each coordinate so that you know. 0. We forgot 0. What was this one? Oh, the first one. This was A. For 0, this is the best one. Let's see, what color? Yellow. 0. 0 is at the origin for this guy. Okay. Hopefully this was very straightforward, this part. What you can do now is you can write your summary. Summary. Fill in your caution signs and your question marks, and then bring them to class tomorrow.